A stereogenic center must fulfill two conditions. The first one, it must be an sp3 hybridized atom. You know that sp3 hybridized atoms have a tetrahedral shape, so I will use any of those two terms from now on. And the second one is that it has to be connected to 4 different groups. Other names that people use are Chiral center, stereocenter, chiral center, or asymmetric center. When trying to identify chiral centers, remember to only consider tetrahedral carbons. You can often identify a stereocenter because it will have dashes and arrows. However, be careful, because that's not always the case. Look at these complex molecules here. They have multiple stereocenters, but since there are no dashes and arrows, you must look closer and look for the groups that each carbon is connected to decide if they are in stereocenter or not. In general, when a molecule has no chiral centers, it's not chiral. There are a few exceptions to that. When a molecule has one stereocenter, the molecule will always be chiral. When there are two stereocenters, there are two possibilities. If the molecule does not have a plane of symmetry, the molecule will be chiral. But if the molecule presents a plane of symmetry, then it will be achiral. A plane of symmetry is a plane that you can draw across a molecule and that divides the molecule in two exact halves. That includes the space orientation as well. As I mentioned in the previous slide, when a molecule presents a plane of symmetry, the molecule is achiral. In summary, we can always draw the mirror image of a molecule. If the molecules are not superimposable, then they are chiral. If that mirror image is superimposable with the original, then the molecule is achiral and will have a plane of symmetry. A molecule with stereogenic centers will be chiral, except for when the molecule has a plane of symmetry.